Hey guys, welcome back to another video. Today we'll be going over LeetCode 242, which is valid anagrams. Let's get right into the video. So, given two strings s and t, return true if t is an anagram of s and false otherwise, right? It's very simple explanation. And what is an anagram? What is an anagram? An anagram is a word or a phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Now, what do we mean? What do we mean? So, look at the examples that they gave us. First word or first string they gave us is S, which says anagram. The anagram right here, and they gave us T, which does not say anagram, but, is it a variation of anagram? Yes, it is. Well, how do we know that? How do we know that? Look, there's an A here, there's an A here, there's an N, there's an N, there's another A, there's another A, there's a G, there's a G, there's a R, there's a R, A, M, and M. And another thing you should notice is that using all the original letters exactly once, meaning they are of equal length. So, what are the things that must be true? What are the things that must be true? Is that every letter must, every character must appear once, at least once, in T. Every S character must appear in T. Now, if it appears twice, as in this case, 3 times A is appeared 3 times, it must also appear 3 times here, right? And they can just be arranged differently. It's true that they can be arranged differently. But what's not true is that they are of different length. So they have to be of the same length for this to be true. So in this case, what's wrong in this case? We can see S is RAT, T is CAR. Now what's wrong? Why is this not an anagram? Well, let's see. We have R here, we have a R here, we have an A here, we have an A here, we have a T here, but there's no T here. There's a C here, but there's no C here. But they are the same length though, right? Well, the length is not the only thing we care about. We also care about the characters matching and having the same amount. So in this case, it's simply just false. It's simply just false, right? So, so let's get into the board. First thing, intuition. What are we thinking of? What are we thinking of? How can we solve this? How can we solve this, right? Well, the first thing that comes to my mind is sorting. Sorting. We can use a sorting. How can we use sorting? Well, what if, right? We're given S, which is car. We're given T, which is arc. Well, when we sort them, what do they become? They both become A, C, R, right? And and since they're both the same, we compare them. We compare S and T, and if they're if they're the same, we return true. We return true. Otherwise, return false if they're not equal, right? It's as simple as that. It's as simple as that. But, but, what if I told you what is wrong here? What might be the issue with this? Well, in case you haven't figured out, we are sorting them. We are sorting them, right? So we're gonna use sorted T is equal to, if you're using Python, sorted S is equal to sorted T. It's easy lines of code, simple lines of code, but the issue here is their time complexity, right? Time complexity. Now, what is the time complexity? Well, since we are using sort, it will be of n log n plus of m log n, since we are sorting both S and T, right? And my question for you is, can we do better? Can we do better? And I'll give you the answer. We can do better. Now it's up to you. I'll give you 3 seconds to figure out what can we use. What can we use to make this better? I'll give you a hint. You can use DSA, data structures and algorithms. So 1, 2, 3. Okay, well, let's get into the optimal solution in case you haven't figured it out, which I really hope you give it a try. Um, so what can we do? What can we do? What can we do? Sorry for my bad handwriting. Please bear with me. What can we do? Well, we can use sort because very bad time complexity. Well, the first thing that I'm thinking of is using a data structure. And this will be my favorite one. Can you think of it? You probably can make the right guess. Well, when it comes to solving something that I usually don't know how to solve, the first data structure I think of is hash hash map hash map. Wow, right? Yeah. Hash map. Well, how can we use a hash map to solve this, right? How can we use a hash map to solve this? Well, I'll tell you. I'll tell you. Let's say we have a S map for our string. Then we have a T map for our T string, right? Now what are we gonna do? We will iterate over S and we will iterate over T. AR and this will be ARC. We'll iterate over both of them, right? We'll iterate over C and we'll iterate over A. And as we're doing them, what are we gonna do? We're gonna, in our hash map, increment the number of times each character appears. The number of times each character appears. So our key, let me just draw this out. Key will be the character that we're iterating over, and our value is gonna be number of appearances. Um, yeah, that should be it. So, it's really as simple as that. I'll just probably guess how this works now, right? So, so let me give an example. So let's say we're iterating over S and T. We have C and A. The first time we iterate, we'll simply just do this. For S map, we'll do C is equal to 1 because it's the first time we're seeing C. For T, we're doing A is equal to 1, right? And next round, now we're at A and R. We're doing the same thing. We see for S, we see A once. For T, we see R once. And then we move on to the last iteration. S, we're seeing R once. And for T, we're seeing C once. Now, after we're done with our iteration, we simply just compare them. Compare S map and T map. If they are equal, if they're equal, return true. Otherwise false. Otherwise false. And what's the time and space complexity? Well, time, since for time, what are we doing? We are simply just iterating over T and S, right? So this would be O of N plus O of M. And the reason for that is because of our iteration for our loop, right? And for space, this will also be constant time. Why is it constant time, you may ask? This is a good question if that you thought of it. Well, at most in our hash maps, we will be storing 26 characters, right? And we won't be going above that. And that's exactly why it's constant. Now that you know that, let's get right into the code. Oh, one more thing. well, I'll actually show you guys in the code, is the first thing you could just do right off the bat is check if length of s is not equal to length of t. Because it's the first thing, that's the first thing I told you guys, right? They must be the same length. And if they're not, we just automatically return false. Automatically return false, right? Now we can go ahead and move on with our code. Now I told you we have an S map. I also told you we have a T map, right? Now, what do we do after that? We iterated over, we iterated over S and T, right? Right? So for I in range, we can just, since they're the same length, we can just iterate over any of them. It doesn't really matter. So for I in range, length of S, what do? We do, we essentially add the character, the first character, or whatever character we're in, whatever I is at, we add that character, for in this case, A, to, we increment the count of A in our S map and our T map. So S, S map at S of I, right? Because we're iterating over S and we need to find the value, equals, what do? We do S map dot get S map. Give me one. All right, guys, someone was at the door. I had to get the door real quick, but let's just continue. So what are we doing here? We are doing smap dot get. Oh, one thing I forgot is we're gonna do one plus smap dot get. We will do. Be 1 second. Someone's knocking on my door again. I'm so sorry. Okay, guys, I'm back. Sorry about that again. Anyways, let's move on. By the way, we're using the get function because the first time, like if we were just to do s of I, this, like in the case that this didn't exist, we would just get a key error. So we don't want that. It's recommended to just do this s of I and then have a default value if this does not already exist, and the default will be 0. 0 will be returned to us as the value if it doesn't exist. And we'll do the same for tmap. Tmap. Now we'll look at um, t of I, and it's as simple as that, right? After we add these, what do? We just return tmap. I mean, sorry, smap is equal to tmap, right? And this should work unless I got something wrong. Did I get something wrong? Let's see. How about you guys debug with me? So, let's see what I could have done wrong. For I in range, length of S so y is equal to 1 plus. Okay, after we add all of these, sorry about that, guys. I just realized what the issue here was. I'm still calling S map instead of T map here. Oh, I can't believe this. Anyways, this should work, guys. Yeah. All right. Yeah. You see it works, and we're good. All right, guys. I'll see you guys tomorrow again, or the next video. Hope you guys enjoyed, and sorry about the stopping so many times.